All right, well, hello everyone. Good morning, good afternoon, and good evening from whatever you're joining us. My name is Dalia, and I work as a community manager here at Kong. I'm super happy to welcome you all to our workshop today, which is about Kong Konnect Automations 101. We have Panagis with here today. He will introduce himself and tell you a little bit about what he does. This webinar is being recorded. You will all receive an email later on with the recording, plus some resources for you to take a look at. Also, we will upload the recording to YouTube, so you can also watch it there. I put the link to our YouTube channel in the chat. So yeah, you can subscribe and get notified anytime we have a new recording uploaded. Yeah, if you have any questions, please put them in the Q&A function rather than the chat, because then we can keep track of all the questions. And Panagis will answer them at the end when he's done presenting. So yeah, please take it away from here.
Thank you very much. Hello, everyone, and thank you for joining today's session. My name is Panos, and I'm a field engineer with the professional services team here at Kong. And today I would like to explore with you how organizations can bring together automation and the capabilities of Kong Konnect to build a comprehensive API management platform as a service, right? So for the ones that do not know already, Kong Konnect is Kong's software as a service offering for building API platforms and innovation factories in general. So here is what we're going to be covering today. First, we will start with a close to real world scenario that illustrates the journey from manual API operations to self-service automation. We will explore a reference workflow for self-service delivery with Connect. We will have actually two live demos putting these concepts into action. And finally, if time permits, we will wrap up with some Q&A. So let's get started with the original hypothesis and scenario. To begin with, I would like to introduce you to Kong Air. Kong Air is a fictional airline that we here at Kong love to use in many of our trainings, demos, and presentations. As part of the scenario, we will examine Kong Air's API management journey, the motivation behind it, and also the challenges they faced along the way. Well, Kong Air, like many organizations today, was struggling with customer expectations. Over the past decade, there's been an explosion of touch points and experiences customers are using to interact with the company. And this evolution happened very fast, right? It started with simple websites, then mobile applications, revolutionized the customer interaction, then chat applications became essential for real-time support, social media integrations became business critical, and nowadays, in our AI-driven era, AI agents are creating entirely new categories of customer experience and demands. And each of those channels doesn't just represent a new interface, right? They represent new technical requirements, new integration challenges, and new customer expectations altogether. The real challenge for Kong Air is that Kong Air is not just an airline anymore. They are expected to be a digital marketing agency, a company, a customer support platform, an AI-powered recommendation engine, and a logistics coordinator, all while still flying planes safely and effectively. So faced with those mounting challenges, Kong Air initially did what many organizations do. They reacted. They reacted and they started building point-to-point integrations whenever a new need arose, and they created new custom solutions for each and every channel. And as a result of that, their IT landscape became a web of dependencies that grew more and more complex and fragile with each new customer demand. The breaking point for them came when they realized that they were spending more time maintaining integrations than building new capabilities that could bring actual value to the customers. Also, their teams were bottlenecked, their time to market was suffering, and they were losing the competitive advantage that they had up to now. And that's when Concur made a strategic decision to build a centralized API management platform with dedicated teams and infrastructure. The first step for them was to structure teams around business domains, following the domain-driven design principles. And this decision was not just about technology, but it was about also aligning business logic, data ownership, and team responsibilities altogether. In the specific case of Conger, since it is an airline, here in the slide, you can see some typical business domains that they decided to use. So we can see here the flight operations domain, ground operations, maintenance, repair and overhaul, commercial operations, customer service, and many more. Their objective was to productize those domains via APIs so that the respective teams can now work on creating the APIs that will expose the functionality and the data that they manage within their own domains. So in order to accelerate this transformation, Conger introduced a platform engineering team. And that platform engineering team had a clear mission to make every API team as fast and as effective as possible. Now, each domain team would work together with this platform engineering team to productize the capabilities through APIs. The platform team would handle the infrastructure setup, the gateways deployment, and all the technical implementation, while the domain teams would focus on their business logic and building and designing their APIs. And of course, Conger's platform of choice is Kong Konnect, right? So how things work in Kong Konnect is that different API configurations are segregated through what we call control planes. So each business domain can get its own control plane for configuration, right? Therefore ensuring isolation and also centralized management. And here in the slide, you can see an example of that setup for the flight operations team. So the idea is that the team develops APIs like the Flights API or the Routes API. Then they publish their gateway configurations to their dedicated flight operations control plane. Then the control plane propagates these configurations to the appropriate Kong gateways. We also refer to them as data planes, right? And once the gateways are configured, then they can start processing incoming API traffic from all applications and services. So by following this approach, Conger managed to build an initial federated environment in which the different business domains can operate independently and manage their own configurations. So Conger built that environment. They managed to go live with the first initial use cases. And their platform approach was a huge success, right? A huge success. So successful, in fact, that more and more teams wanted to jump on board as quickly as possible. But with this success also came the growth challenge. Success brought new demands, and Conger faced a classic scaling problem. They realized that what works for 3, 4, 5 teams doesn't necessarily work for more than 50 or more than 100 teams, right? So as more and more teams wanted to join the platform, several issues started to surface. First of all, onboarding bottlenecks. So the manual or semi-automated team onboarding process was taking days and in many cases weeks of platform team effort for each new domain team that wanted to onboard the platform. The platform team also found themselves doing the same setup tasks repeatedly, like creating control planes, configuring access, setting up gateways, setting up monitoring, CI/CD pipelines, and so on and so forth. Also, because of that, some more self-sufficient domain teams were starting to get frustrated because now they had to wait for the platform team's availability, and they had to adjust their own timelines based on another team's capacity instead of their own readiness. So all those factors led to the platform team paradox. This paradox is that the very team that was supposed to accelerate everyone else now had started to become the bottleneck. So facing that challenge, Kong realized that they needed a fundamental shift in their vision, right? They had to evolve from their platform-assisted model to true automated self-service. The new vision was to transform the current platform into a platform that works like the modern cloud providers do, where teams can provision resources, deploy APIs, and manage their entire lifecycle without human intervention from the platform team. Think about how you would interact today with AWS or Google Cloud, for example. You won't be picking up the phone to call anyone or submit tickets for more services. What you would do is that you would simply consume the capabilities you need through well-designed APIs and automation. And this is exactly the self-service experience that Kong Air now needed to create for their internal teams. To achieve this transformation, they knew that they had to fundamentally reimagine 4 key aspects of their platform operations. First, full self-service onboarding had to become reality. Second, they also needed to introduce infrastructure autonomy, where the more self-sufficient teams, the more self-sufficient domain teams could independently request and operate all the services and resources they needed and they required for their APIs. Also, the platform team's role now needed to evolve as well, with a clear focus this time on strategy over operations. So the platform team, instead of being the kind of human automation layer, they would now need to focus on building technical assets and capabilities that enables others to be successful, that enable others to be self-sufficient. And of course, finally, the entire system had to be able to support scalable operations, meaning that the platform should be able to grow to support more than 50 or more than 100 teams without requiring proportional growth in the platform team itself. And this is where the platform as a service concepts become essential. And this brings us to the heart of this workshop, which is exploring how can we approach self-service with Kong Konnect, while also bringing in a few popular tools to round out the end-to-end implementation. So for today's demonstration, for today's demos, this will be our tool stack. Um, of course, at the center, we have the Kong Konnect API management platform, but we will also be using GitHub and GitHub Actions for repositories and reusable technical assets. We will be using Terraform, primarily leveraging the official Kong Konnect Terraform provider for our infrastructure as code processes. We will be using an S3 compatible storage to store our Terraform states. And last but not least, we will also be using a vault, in our case, HashiCorp Vault, for storing secrets and sensitive information. Now, bear in mind that when it comes to the Kong Konnect Terraform provider, we won't be doing a deep dive into that today, right? There are plenty of great tutorials and walkthroughs from my colleagues that you can find easily with just a quick search in Google or YouTube. Instead, in this workshop, I'd like to take things up a level, looking at the bigger picture and focusing on how to bring all those different platform pieces together in a way that works efficiently, right? So before we start, the first thing we need to understand is how programmatic access works in Konnect. Programmatic access in Konnect is provided via what we call system accounts. System accounts are accounts that are not tied to a specific user and are inherently designed to be used with CLIs, pipelines, or other automation methods. What makes the system accounts powerful is that they can belong to a team. They can also be assigned their own roles and permissions, therefore controlling what they are allowed to do in the platform. And of course, they can be assigned access tokens that will be used as the credentials to authenticate and interact with the respective Kong Konnect APIs. And that being said, let's now try to put the platform engineering hat on and try to explore what is, in my opinion, the most important part of providing a platform as a service. And this is self-service onboarding. How different teams can onboard the platform and start using the platform capabilities in a secure and governed way. When we approach self-service onboarding, the first thing that we need to decide about is our system of record. So what will be the single source of truth that holds the authoritative information about the teams onboarded in our platform and the entitlements or the access levels those teams have on our platform. Now, depending on your organization, tooling, and landscape, this system of record can take many forms. For example, it might be a dedicated database table where you store team identities and access levels. If you are already invested in an ITSM or CMDB tool like ServiceNow, you might want to leverage that as your authoritative store. Or in some cases, it can be something much simpler and pragmatic, like a version controlled folder within the platform engineering teams repository, where each team's record lives in there as a file, right? So the key point here is not what technology you use, but what everyone agrees it is the single authoritative source. All automation, workflows, and onboarding processes should rely on this very source and only this source. to prevent, drift or conflicting records. For our examples, in our demonstration, we will use well-governed version files stored in the platform teams repository as a system of record. And specifically, we will go with declarative YAML files that look like this. Keep in mind that these structures are not standard format, right? It's just something that I put together for the demo just to illustrate the concept clearly. The key takeaway here is that for each record, we need to have a structure that clearly defines the onboarded teams information, their access levels, and most importantly, can easily feed into our automation logic. For example, let's say that we have a record for the flight operations team. When our automation processes that record, it will automatically provision the flight operations team. It will create the corresponding system account and also assign the entitlements defined in the record by mapping them to the correct roles on that account. Now, the entitlements you see here is again an abstraction, right? So think of the entitlements as an abstraction to a group of roles that will allow you to perform a specific set of actions on the Konnect platform. For example, if you check the entitlements that are defined here, the control plane entitlement via our automation will be mapped to the control plane's viewer and creator role. That means that whoever has this entitlement will be able to view, create their own control planes, and also get administrative rights on those control planes. They will also be able to manage those control planes. Same for the Konnect API entitlement. It will be mapped to 3 different roles, to the API's viewer, creator, and publisher, which that means effectively that whoever has that role will be able to view APIs on the platform, create their own APIs in the platform, and also manage their own APIs in the platform, and also be able to publish them on the Konnect developer portals. With this in mind, we can move forward and explore the implementation of a full self-service onboarding experience. Here you can see a reference approach, right, of full self-service onboarding process. So when we talk about onboarding, almost every time the first step, everything starts with the onboarding request, right? So that the team that wants to onboard the platform submits either an onboarding form or maybe a PR directly to the platform team's repository. Then the platform team will review that pull request, will review that onboarding request, and either accept or reject the onboarding. And if the onboarding request is accepted, then the full onboarding workflow, the full onboarding automation will automatically start. And what will happen during this onboarding automation is that first, the required teams and associated RBAC resources that are given programmatic access will be created on Kong Konnect. Then a dedicated vault for the onboarded team will be provisioned with the appropriate policies that will store this system account token for programmatic access. Also, a team repository will be provisioned and also pre-configured with initial templates and access. And when all those resources get created and once all those resources get glued together, then the onboarding process would be considered completed, and the team will be able to immediately start using the capabilities of the Konnect platform depending on their access levels. So let's see how all of these things look like in a demo. So first of all, let me show you my setup. Here, as you can see, I am already logged in to my Konnect organization. If I go to my organization page, I will see that in my Teams page, I don't have any teams onboarded yet. Only the predefined Konnect teams are mentioned here. Then we have our S3 buckets, our S3 storage. Then here we have our HashiCorp Vault, right, where we will be storing our secrets. And we, of course, have the platform engineering teams repository, a reference repository that the platform engineering team is using. And this is where the magic happens. So let's take a look to what is included in this repository. First of all, we have our teams folder over here, which, if you remember, this will be the folder that we store our system of records. At this point is empty, but eventually it will contain all the records of every team that is onboarded in our platform. If we check under the GitHub folder, here is where we have all of our workflows, all of our automations, and also here is where we will also maintain all the technical assets that the domain teams will be able to directly consume from this repository once they onboard our platform. But since the first demo is about onboarding, let me guide you through the onboarding workflow, which is this onboard connect teams.yaml workflow. So what this workflow does is that it monitors our system of records folder for changes. So if a new team record was added, if a new team record was deleted, or if a team record was updated, and if any change happens, then it will automatically trigger the onboarding job. This onboarding job is a fairly simple job. So what happens here is that we first, of course, define some required environment variables for our Terraform project. Then we are installing some dependencies over here. After that, we are validating each and every team record that exists in our teams folder, just to make sure that the structure is correct, right? And we do not have any unpleasant surprises. We also ensure that there is a Terraform state bucket that it can hold our onboarded teams state available. And if everything is in place, then we initialize our Terraform project and we run our Terraform automation. Let's also take a look how this Terraform onboarding project looks like. So the most important files to examine here is, of course, the variables.tf file, where we declare our input variables. And as you can see, the path to our resources directory, the path to our system of records directory is a required variable. We also have a modules folder here where we have developed a couple of modules that depict the resources that we will be creating with each and every team onboarding. Now, those modules leverage the official Konnect Terraform provider and also the Vault provider under the hood in order to create the appropriate system accounts for every team, to assign the appropriate roles according to the team's entitlements, to create the system account access tokens, and of course, provisioning a vault for each team and also storing those system account tokens in the vault. And of course, the last file that we have in here is our entry point, the main.tf file, which is the entry point of our automations. And what we do here is that, as you can see, we are reading all the YAML files that we have in our teams folder. So we're reading all the teams that should be onboarded in our platform. Then we're just putting those teams in a structure, in a list structure, so that it's easier to iterate and manage in the course of the code. And then once we have all the onboarded teams records available, then we go ahead and we create the appropriate Konnect teams. For each team, we create the appropriate system accounts, the appropriate system account roles based on the entitlements defined within each team's record. And we also create the system accounts access tokens. As a third step, this is something that is not in scope for this demo, but we also need to provision the teams repository and also pre-configure it with the initial, templates, the initial folder structures, and also the initial access levels, right? For the demo that comes afterwards, I have manually created a reference teams repository, so I will show you a bit later how this repository will be leveraged by the teams themselves to provision their own resources. Afterwards, what we do is that we create the necessary Vault integrations for each and every team, and also we store the generated system account access tokens in the Vault. And last but not least, we are creating also S3 buckets for each and every one of the onboarded teams so that they can leverage those S3 buckets to store their own states, their own Terraform states, and also any other resources that they might want to store over here. So technically, this is how the platform operations repository looks like. So now let's see how this whole onboarding process would look like. What I also have here is that I have created a very, very simple onboarding form. So let's assume now that I am, for example, the product owner of the flight operations team. And I want to onboard my team to the platform so that they can start using the platform, creating, their gateways and so on and so forth. What I would do is that I would open this form and I would fill in my team's information. So, for example, my team's name would be flight operations. My team description would be flight operations team. My team's contact email would be flight operations at kongair.com. And now for the entitlements, I want my team to be able to create and manage their own control planes so that they can also spin up their own gateways if they want. And I also want them to be able to create, manage and also publish their own APIs on the Konnect developer portals, right? So this is why I'm going to select both of those entitlements. And I'm going to submit the onboarding form. So once the onboarding form gets submitted, then automatically a pull request will be generated in the platform teams repository, indicating that there's a new team that wants to onboard the platform. And now from here, a member of or an administrator of the platform engineering team can easily go in, review this onboarding request. As you can see in this instance, this pull request will create a new team record under our teams records folder. And we can see that this team new record is about the flight operations team. And these are the entitlements that the team is requesting from the platform. And here, the representative of the platform team can either approve or reject the flight operations team onboarding request. Of course, I'm going to approve the onboarding request. I'm going to review it. I'm going to give my OK. And once everything is completed, I'm going to merge the pull request to main. And as you can see here, once the pull request is merged to main, then our onboarding automation starts. And as we mentioned before, what it does, it will validate the configurations of all the records, of all the team records. It will ensure that this bucket exists, and then it will run the Terraform automations to provision the resources in Konnect, the resources in the vault, the team's repositories, although this one isn't doing that. And once this automation concludes, that was it. The flight operations team is now onboarded to our API management platform. So let's take a look at the resources that were created during this onboarding automation. So if we go back to our Konnect organization and back to our teams and refresh, we will see that now the flight operations team is created. We will also see that the flight operations system account is also created and assigned to the specific team. And in terms of the system account roles, as we can see here, the system account has now the creator and the viewer role for the control planes. As we mentioned, this means that this system account has programmatic access to view, create their own control planes, and administer the control planes they have created, right? This happens because the creator role is a bit of a special role, right? The creator role allows you to both create resources in Konnect, and automatically, for every resource you create, you become the administrator of this resource. And of course, for our APIs over here, we can see that the system account, the flight operation system account, has programmatic access to view, create, manage, and publish their own APIs on the Konnect developer portals. And apart from that, for the system account, we can see that also a system account access token was generated, which is also safely stored, Give me a second, under the newly created flight operations key vault under system accounts, the name of the system account, and then the token, right? So at this point, the flight operations team is fully onboarded the platform. All the required resources have been provisioned, and as a part of the process, the team also received its own repository, which looks like this, right? So for every onboarded team, we get a, a repository assigned to the specific team. And this repository is pre-configured with starter templates, with workflows, and also the right access levels to be able to access the team's vault, to be able to access, all the components that needs to access when we start using the automations. And the important thing here is that from here on, from the flight operations team, every interaction with the platform will happen through that repository and only through that repository, right? So let's now put our flight operations team hat on and see what happens once they are onboarded, how they can start using the platform's capabilities to provision resources, to provision the resources that they need, and start exposing their APIs to customers. So let me go back to my slides and show you the next slide, which deals with self-service resource provisioning this time, right? So once we are onboarded, how do we provision the resources that we want in the platform? So the first step for the flight engineering team, the flight operations team, sorry, is to decide which platform resources they need to use, of course, always depending on the entitlements that they have, right? So in their case, to get started, they need gateways to expose their APIs, right? And to run those gateways, they'll first need to provision control planes for each and every environment. In order to do this, the team will need to declare the required control planes in their own system of record this time, which will live in their own repository, and then trigger a platform-provided GitHub action. And once that action gets triggered, then it will take care of provisioning the required resources, validating success, applying any required governance policies on top of those resources, and finally, giving the team immediate programmatic access to their control planes. So let's see how this would work in action. So like we mentioned before, this is a reference repository generated for the flight operations team, right? So if we jump back to the flight operations team repository, there are a couple of key spots to check out. First, this Connect folder over here. And inside this Connect folder, we find a resources.yaml file. This file will act as a system of record for everything that team wants to provision and consume from the platform, right? Now, again, like before, the format that you see over here is not an official standard, right? It's just a simple structure that I put together to demonstrate the idea of the system of record. You could, of course, design your own format if you like, depending on your requirements. But the only thing that matters here is that this is the file that we will hand off to the provisioning automation, right? So this is the file that we will feed to the provisioning automation in order to provision the resources that we need. So as you can see in this example over here, the team has already declared 3 control planes that they want to provision, right? One for their development environment, another for their staging environment, and another for their production environment, right? So let's see how can they actually provision those. If we take a look at the repository's workflows, we will see that together with the repository also came this workflow pre-bundled inside, right? So this is the workflow that is responsible for provisioning whatever resources are declared within the team's system of record. So what this workflow is doing is that it will first authenticate against the team's vault, and it will retrieve the team's system account token, and then it will call an action from the platform team's repository, right? Also passing in as inputs in this action the path to the resources file, the system account token, right? And some other inputs information that are required to authenticate with the different components that will be a part of this resource provisioning automation. Now, this action over here is owned and maintained by the platform engineering team, and it lives under the platform engineering team's repository, under the GitHub Actions folder, right? So this is this is an action that is provided as a product, right? As a reusable action by the platform engineering team for other teams to use as well. So when this action runs, what it does is that it sets up Terraform. Like before, it validates the inputted resources file, then using the relevant inputs over here and some information from the resources file, from the team resources file, it sets up, it declares, it defines, some environment variables and some Terraform environment variables, and then it runs the Terraform automation to provision the resources the team requested. If we dive deeper into the Terraform code of this action, again, the key files to pay attention here is the variables file, where we declare our input variables, so that you can see that here variables like the team name, the path to the connected resources file are defined, the connect access token, which is effectively the system access token of the respective team, is defined, and a bunch of other required variables. We also have created some modules over here. Those modules represent the resources that the team is allowed to request, to provision. So if you see in our examples here, we have an API module and a control plane module. Those modules are leveraging, again, the official Kong Konnect Terraform provider under the hood in order to provision the respective resources. And then, again, we have the main.tf file over here, what we're doing is that we are reading the team's resources file. We extract the declared resources into their own variables, and then we invoke the appropriate module to provision the resources requested by the team. So that being said, let's get back to the flight operations repo, to the flight operations team repository, and see how that would work in action, right? So just as a recap, the flight operations team has declared that they want to provision 3 control planes so they can start spinning up their API gateways. So what they will do is that they will simply run the provision connect team resources action. They will run this workflow, and once the workflow steps are completed, like we explained earlier, you can see here all the resources that the Terraform code, that Terraform will provision, right?
We only have a few minutes left. We're almost
Yeah.
out of time, so
Yes.
if we can do the questions. Thank you.
This is the last demo.
Amazing. Thanks.
So once the automation is concluded, give it a second. Oh, nice. Nice, it failed. Let's rerun the job. Nice. Oh, it failed again. Let me try one last time, because sometimes there is some weirdness in the action. And if it also fails this time, I will just explain what would be the actual result, right? So we do not waste any more time. Okay, now it succeeded, right? So all the resources that we saw declared by the platform engineering team, the flight operations team, should now be available in our Connect platform. So if we go to our gateway manager, we can see that we have our developer, production and staging control planes provisioned. We can also see that every control plane is also pre-configured with the respective data plane certificates. And also, if we go back to our vault, we will see that now for every control plane that was provisioned, we have all of the respective control planes connectivity information available in the team's vault and safely secured and stored in there. So we can see our clustering certificates available here, the control plane endpoints. Now, having all those information available, now the flight operations team can start spinning up their gateways, connecting them to the appropriate control planes, and start exposing their APIs to their customers. But this is not something that we will cover in this session. This is something that we will cover in the next session of this webinar series, which will be, I think, Dalia, the 23rd of September, and it will be facilitated by my dear colleague, Jordi Fernandez. So that was all. That was it on my side. Thank you all for your participation, your time, and your patience. And yes, Dalia, back to you.
Amazing. Thank you so much. Let's look now at the questions. In the Q&A function, we have 4 questions so far.
Yes.
Yeah.
Let's check the questions. sorry, can you?
Yeah, can you see like on the bottom there should be a Q&A function.
Yeah.
Can you see it? It's next to share. And raise your hand.
Yes.
Yeah,
Sorry,
perfect.
sorry, folks.
No worries.
I'm all over the place. I have 3 screens over here, and I was over the place trying to find the screen.
Happens.
Okay. Andrew asks, to onboard a team, you will need a connect token to run the TF to create all the entities. What's your recommendation for setting that initial system account up? It's a little, yes. So Andrew, that's actually the $5 million question, right? Because indeed it is a chicken and an egg. So my recommendation would be that you need to at least manually create a system account token with the organization admin permissions, and then safely store it in a vault, right? That you can then pull every time you want to run, those connect platform operations functions. So yeah, I don't know if that was a satisfactory enough answer, but this is indeed a chicken and egg question, and this is how, at least up to this point, this thing can work. So Ben is also asking, this demo assumes control plane as the team boundary. As number of teams increase, so will the number of control planes, multiplied by the number of environments. If teams, proliferation of control planes, it will be very hard to scale. Why would it be hard to scale? Because, the control planes do not affect, scale. But I do understand your question, and this, of course, has to do with the boundaries that you want to set in your own organization, right? So the demo that I showcased today was just, meant to showcase an initial approach on how would you approach providing a platform as a service to your teams, provided the fact that the teams, right, are able, right, to provision and to request their own resources. If obviously, if at the organization level, right, the amount of resources the team can provision, or the amount of assets that they can own themselves has a limit, right? Then obviously the whole process needs to be amended a bit and to be governed better, right? So for example, you can say that, okay, every team can at max provision 2 control planes, and then during the automations, right, you have a fail gate that checks, okay, how many control planes this team already has. Is it more than 2? Then I reject the 3rd control plane, or something like that, if I understand correctly your question. What do you recommend for the platform team to manage Godot plugins that you do not want app teams to have to manage? Yes. So, Adu, this question, doesn't. It's a very valid question, right? But the approach that I showed is that you give your teams absolute freedom, right? An absolute kind of eat your own dog food situation, right? So you allow the teams to request resources, and then they are responsible of how they configure their APIs, responsible of how they manage their APIs, and they are responsible for enforcing their own policies into their own control planes, right? So this was the idea of the full-fledged platform as a service. But of course, this approach can also be amended, right, in order to have more governance over what is initially shown in the demo. In this demo, how do you recommend handling token expiry and rolling? Yeah, this is something that, of course, was not in scope for the demo because these are nuances that come afterwards, right? The purpose of this demo is to just showcase an initial approach of approaching the platform as a service concept. But yes, indeed, the token expiry and rolling is a very, very legit concern. And there are multiple ways that you can handle it. For example, one way is that the way the Terraform code works, right? The Terraform provided works is that if you apply again the same Terraform state, then automatically the tokens would be rolled, right? Would be rolled. Or otherwise, you would probably need to come with better ways of handling token expiry like that. It really depends, right, on what you want to do. I'm sorry I wasn't able to be more precise in the last question, right? But it's a very, specific, right, question that was not accounted for in this demonstration.
Well, thank you so much for answering all the questions. We can connect also with Andrew on the community Slack if he has any more questions. Yeah. Really appreciate it.
If you want to dive deeper, of course.
Yeah. Well, thank you so much for the presentation. It was amazing. Thank you everyone for staying, for asking so many questions. We hope you enjoyed it, and you will receive the recording either later today or tomorrow, plus some additional resources. And we hope to see you on September 23rd for the second part of this webinar series. And yeah, thank you so much.
Thank you very much.